Welcome students again to our third session. This session we are looking at the inverse of a matrix, and we're looking at the application of the inverse of a matrix. So first thing we're going to look at is how it's indicated, and what you will see when asked to find the inverse. You will actually see them. We're looking at matrix A on the screen, and if asked to find the inverse of matrix A, you will see A to the power minus 1, which simply means to find the inverse of the matrix. And to find the inverse of the matrix, it's 1 over the determinant of the matrix, the determinant of A, by the adjoint of A. Now that means you're supposed to know how to find the determinant and how to find the adjoint. But if you can't remember, we'll just quickly recap. The determinant of A, you multiply the main diagonal, so it's going to be 2 multiplied by the 4 minus the multiplication of the minor diagonal, which will be 1 multiplied by 1. So it's going to give us 4 by 2 giving us 8. 1 multiplied by 1 is going to give us 1. So 8 minus 1 giving us 7. So the determinant is going to be equal to 7. So far what we have is our A inverse is equal to 1 on 7. The next part we have to find is the adjoint. The adjoint of A. Again, we did this before, but we recap it again. The adjoint of A, you interchange your main diagonal, right? And now you change the sign of your minor diagonal. If it's positive, it's change to negative. If the components are negative, change it to positive. So we have -1 and we have -1 here. Alright? So what we have our determinant and we have our adjoint, and we combine them together and we will get our inverse. So I'm just going to be a little bit lazy here and quickly copy it, just paste it together. So this represents my inverse. 1 over the determinant of A by the adjoint of it. So I'm circling my answer here. Now my answer could also be stated as A inverse is equal to, you have 1/7. I could act as a scalar. It's just a number, and I can multiply it into the matrix, and I get 4 and 7 minus 1 and 7 minus 1 and 7 and 2 on 7. Both are correct. You can either use either one or state them as either one of these. So you have your inverse stated here on the screen. Now, the next thing, what do we use this for? We could use this to perform calculations, and the application of this would be to actually take a simultaneous equation and using either what you will see is sometimes saying using the matrix method or the inverse matrix method to solve the simultaneous equation. And that's more or less straightforward. First what we have to do is we actually have to take this matrix, take the simultaneous equation, and express them in matrix form. So I'm just going to clear the screen because we already have our inverse. We're going to keep it on the screen. We're going to use the same screen and just clear it up. And we want to take this matrix and represent it get into our simultaneous equations, and using the matrix here, we are actually going to come back to this solution that we have on the screen. So we take in the simultaneous equation and represent them into matrix form, and you realize we get 2, 1, 1, 4, alright, multiplied by xy is equal to 5, 6. So we have taken our simultaneous equation, represented in the matrix form, and you would notice that if I was to multiply it out, multiply these first two matrices, it's a 2 by 2 multiplied by 2 by 1. So it means that they can multiply because the inner two numbers are the same, so they cancel out, and my outer 2 represents what I'm going to get as my final answer, which is a 2 by 1. So everything is in keeping with what we know so far. Alright, now we have A, which is A, multiplied by which is X, is equal to B. Now before we even move on with this, I'm just going to clear up the screen a little bit, move some of the stuff off the screen. We want to actually look at what we are doing here. We do not have division in matrices. So I'll take you away from this question for a moment and just do an explanation. If you had 2 multiplied by some box is equal to 10, it's easy to see that the box is equal to 10 divided by 2. But then we know that multiplication doesn't exist. So how else could we actually do this? And I want you to think along the lines of moving the 2 over to the opposite side of the equal sign. And also remember, whatever you do on one side, you must do it on the opposite side. So let's say we multiply both sides by a half. A half on the left hand side, and you multiply by a half on the right hand side. What happens to the 2? Cancels out. A half multiplied by 2 gives us 1. As in 1 by the boxes will give us a half multiplied by 10 is going to give us 5. So it means that the box is equal to 5. And that's exactly what we're going to do with the matrix. We are actually going to multiply both sides by the inverse of A. And when we do that, we do A inverse of both sides. A multiplied by A inverse gives you not 1, but what we call the identity matrix. And let's explain what the identity matrix is. The identity matrix is basically a matrix where the only position that has a number is in the main diagonal. So 1 and everywhere else is 0. So that represents the identity matrix. And what's so special about it? Any matrix multiplied by identity matrix will give you back the matrix itself. So the identity matrix multiplied by X is going to give you back X. And let me state it again. Any matrix multiplied by the identity matrix is going to give you back the matrix itself. So we multiply A by A inverse, we get the identity matrix, and the identity matrix multiplied by X is going to give us the matrix X. So we multiply by the A inverse on the left hand side, we do the same thing on the right hand side, so we get A inverse B, A inverse multiplied by B is going to give us back, multiply them together, and it's going to give us X, the actual matrix that we were looking to find. And this here, where I'm putting the arrow, represents our X. So all we have to do is find our inverse, multiply it back by B, and we get our matrix X. And remember, we did this already. We found the inverse of A, and I'm just going to pull it back up on the screen here. So my inverse, and I'm going to use the inverse in this format, because now we could use both, nothing's wrong with it, but I'm just going to borrow it and use this format. I'm going to use it in our calculations here. So I have my inverse. I showed you earlier how to find the inverse of A, and this is my A inverse, which I'm putting into the expression here. Just do a quick cleanup. So it's going to be my A inverse, and I'm going to multiply it by my matrix B, which is going to give me my X. So X is going to be equal to A inverse, which we have here, multiplied by B. And remember what B was? B was 5, 6. So let's put it there. 5, 6. Now keeping the 1/7 out of it makes your calculations a little simpler. Alright? Now X is actually what? The matrix with the component X and Y, as you can see. So I'm going to take that off and just put my X and Y. I'm just going to put my X and Y on the screen here. And all we're going to do is actually multiply it out. And we know how to multiply it out already because we've done this before in the previous presentation. So we're just going to remind you again, this is a 2 by 2 matrix multiplied by 2 by 1. The inner 2 is going to cancel out and the answer is going to be a 2 by 1. So the important part to look at is that you're actually going to get a 2 by 1 which represents your answer. So let's multiply it out. Row by column. 4 is going to be 4 by 5 minus, well, we could say plus the minus 1 by 6, and then we go minus 1 by 5 plus the 2 by 6. And remember, this is going to represent my X and Y. Now what we're leaving out, remember that 1/7 is in front there. So it's going to be 1/7 So let's look at it again. We are actually multiplying our A inverse multiplied by B, and to do that it's going to be row by column. We check to make sure the multiplication can take place, and it's going to be 4 by 5 plus the minus 1 by 6 and the minus 1 by 5 plus the 2 by 6. Now remember, it's 1/7 of this calculation because we had left our 1/7 outside. So we do our calculations, and just look how simple it is. I'm just going to change colors so we could clear it up. 5 by 4, 20, and 6 by 1 gives you minus 6. Alright, so 20 minus 6 is going to give you 14. So it's 14 divided by 7, so we get 2. Everybody follow that? And then we go 5 by 1, which gives you negative 5, plus 6 by 2, which is going to give you 12, and it's 12 minus 5, which is going to give us 7. And remember that 1/7 on the outside, so it's 1/7 of that, which is going to give us 1. So what we get as our answer is X is equal to 2 and Y is equal to 1. And my answer could be stated like this, or could be stated as 2, 1. So very simple. All we have to do is notice what we basically did here is that we took the steps that you've done before, and let's recap it quickly. We did the determinant, we did the adjoint, and we're taking determinant and adjoint and actually making it apply it, because we had to use that to find our inverse, and now after applying it to the inverse, they're taking the inverse and applying it to the simultaneous equations. And some important points to note. You realize that you must apply your inverse in the correct position. If you are putting your inverse in from the left hand side, as we indicated there, on both sides of the equal sign must be applied to the left hand side. Remember, what you do on one side of the equal sign must be done the same way on the opposite side of the equal sign. So we applied our inverse on the left hand side. Again, you have to apply to the left hand side. And let me explain. It means that we could not have said x is equal to b a inverse. That's not correct. We had, based on how it's laid out there, if ax is equal to b, then x is equal to a inverse b, not b a inverse. Remember, when we did multiplication, we showed you that AB is not equal to BA. Also, another point that should be taken into consideration, look at your dimensions, look at the size of the matrices. Our A inverse is a 2 by 2 matrix. A 2 by 2 matrix. Right? That's a little small there. Let me just take it off and do it again. And our B was a 2 by 1 matrix. So A inverse was a 2 by 2 matrix, and our B was a 2 by 1 matrix. So we multiply, and our answer is going to be a 2 by 1. If we reverse the order, then we would have had, as indicated on the opposite side of the screen, you would have had a 2 by 1 matrix, which is B, multiplied by a 2 by 2 matrix, and of course that could not be multiplied because the rule says that the inner two numbers must be the same. So you see there are a number of things that tell us exactly where to put what and how to do our calculations. I hope you found this informative, and I hope you were able to follow the steps to getting the answer. Good night, everyone.